All right, this is section 5.6, and this is part 2 of a 2-part video covering definite integrals using substitution. So if I look at this problem example number 4, it says evaluate the definite integral from pi over 6 to pi over 2, cosecant squared x, cotangent x. So I'm going to actually use substitution because I do not have any rule that would take care of this product we have here. But what I'm going to do is I'm going to actually let u equal cotangent x dx. So this would be my leftover, okay? And the reason why I picked that is because I don't think I'm going to be able to find something to take a derivative and go to cotangent x. It's not going to work. So I'm going to go ahead and take u equals cotangent x, and therefore du equals negative cosecant squared x dx. Okay, this almost looks like that leftover with the exception of the sign. So negative du equals a negative times a negative cosecant squared x dx. And now this works, okay? Because a negative times a negative will give me cosecant squared x dx. Okay, so now we're in good shape. Okay, so the other thing I have to do is, remember, we're doing substitution here. We have to substitute for the lower and the upper limit. So let's do the lower limit first. The lower limit was pi over 6. Okay, we now said that u equals cotangent at x. Okay, so u equals cotangent at pi over 6. By the way, this is 30 degrees. So cotangent at 30 degrees equals radical 3. Okay, the upper limit. Okay, the upper limit says that x equals pi over 2. So I'm going to plug in u equals cotangent x. I'm going to plug in for x. So u equals cotangent pi over 2. Remember, cotangent is opposite, or adjacent over opposite. It's the opposite of tangent, right? Adjacent over opposite. So if we put in the values there, we get cosine over sine, or 0 over 1, which equals 0. Okay, so now it's time to write it. So let's go ahead and write this all out. So the new limits of integration, the lower one was radical 3, and the upper one 0. And now I have u times negative du. Okay, I'm going to bring the negative out. And I'm going to look at this for a second before I do anything else. Notice that my upper limit is smaller than my lower limit. So there's a rule that says if you want to make them change, you have to bring out a negative sign. So to change them, what I'm going to do is bring the radical 3 on top, the 0 on the bottom, and then we're going to multiply that by a negative. Okay, and that's once again what I did here was I used a rule to be able to change the upper limit and the lower limit, but remember you have to bring a negative out. So a negative times a negative is a positive. So basically what I have to integrate is 0 to radical 3 u du. Okay, if I integrate u du, what I'm going to get is u squared over 2. I'm going to use rule number 2. And I'm going to integrate that from 0 to radical 3. Okay, so it's time to, the last step is to evaluate. So if I evaluate this, remember I'm taking f at b minus f at a. So this is going to be radical 3 squared over 2 minus 0 squared over 2. Radical 3 squared is 3. So I get 3 halves minus 0, that's 1.5. And that's your answer for example number 4. Okay, let's look at the last example in this section, which is example 5. Evaluate the definite integral from 0 to pi over 2, tangent x over 2 dx. All right, guys, so what we probably should do is let's go ahead and rewrite this as 0 to pi over 2 tangent of 1/2 x. That looks a little better. Okay, So the reason I wrote it like that is because remember I have to use substitution because I can't handle 1/2 x inside with tangent. So what we're going to do is we're going to let u equal 1/2 x. So therefore du equals 1/2 dx. That does not match my leftover, which is just dx. So what I have to do is multiply both sides by 2. So 2 du equals dx. Okay, now this checks out. This matches my leftover. Before I rewrite this, remember I have to take care of the upper and the lower limits. So the upper limit, remember that x equaled pi over 2. And now I have u equals 1/2 x. So I'm going to plug in for x. So u equals 1/2 times pi over 2. So u equals pi over 4. That's my upper limit. Okay, my lower limit. My lower limit is given as x equals 0. So u equals 1/2 x. So u equals 1/2 times 0, which is 0. So my lower limit is 0. Okay? All right, now we're ready to rewrite this thing. So let's write it up. So I'm going to integrate. The lower limit is now 0. The upper limit is going to be pi over 4. And I'm integrating tangent u times 2 du. Okay? So what I'm going to do is kick the 2 out. And I'm going to integrate tangent u du. Okay? All right, so we definitely have a rule for tangent u. So it's time to do integration. I'm going to take 2 and I'm going to integrate tangent u du. Okay, and I'm going to worry about the upper limit and the lower limit in a minute. But when I integrate that, I get negative 2 times the ln of cosine u. Okay? All right. So my next step is to evaluate it. So I'm going to evaluate it. Remember, we're evaluating this function from 0 to pi over 4. So I'm going to take f at b minus f at a. All right, so f at b, negative 2 times ln of cosine of pi over 4 minus negative 2 ln of cosine at 0. Okay, so let's go ahead and figure this out. This is going to be negative 2 ln. Cosine at pi over 4 is radical 2 over 2. And then we're going to subtract that from negative 2 times cosine at 0. Cosine at 0 is 1. So cosine, like ln of 1, remember, equals 0. So I'm going to get negative 2 ln of radical 2 over 2 minus 0. So we have negative 2 ln of radical 2 over 2 as my answer. Okay, and that's it.